application problems give us a little bit of context for our mathematics. So well, first of all, these are calculator active, which means you're probably going to need a calculator to do the work on this. So have one handy. It doesn't necessarily have to be a fancy calculator. A four-function calculator or the one on your phone would work just fine here. Okay, so with a word problem, you have to read the problem first so you know what's going on. It says the number of deer P at any time T in years in a federal game reserve is given by this function here. P of T is equal to 800 plus 640T over 20 plus 0.8T. Okay, so since they gave me the function, my job is to figure out what the variables mean. Once I know what the variables mean, then I can do anything they ask me to here. So they say P is the number of deer, and they say T is the time measured in years. So now I understand the function. So when they tell me to find the number of deer when T is 15, 70, or 100, I know that what they're saying is to find P when the number of years is 15, 70, and 100 respectively there. Okay, so using function notation, that would just mean I put 15 in for T. And so this would say P of 15 is equal to, and that means literally just replace all of the T's in the function with that number. So I'm going to start off with 800 plus 640 times 15 over 20 plus 0.8 times 15. And then I would do some punching buttons in my calculator. Now the first thing I would put in would be that top part there, that 800 plus 640 times T times 15. I got 10,400 for that. So I'll write that down. And on the bottom, I need 20 plus 0.8 times 15. And I got 32 for that one. And so then finally, I need to divide those. So 10,400 divided by 32. And I got 325. So I'll write that on the line there, 325. So if I were to interpret that answer, that would mean at time 15 years, there were 325 deer at this federal game reserve. Then I'll do the next one there. So P of 70. So that means, again, I'm just going to put 70 in place of the T's in the problem, in the function that was given. And then once again, I'll calculate the numerator and then calculate the denominator separately. And then once I have those values, I'll just divide them. This time I got 600. Okay, so again, interpreting that answer, I would say at time 70 years, the population of deer was 600. Now would be a good time to pause the video and try that last one. Try P of 100, and then come back and see how you did. When you put in 100 in place of the t's, you should have gotten 648. So you would interpret that to mean that at time 100 years, the population of deer in the Federal Game Reserve was 648. All right, so moving on. Next, they asked me to find the horizontal asymptote of the graph. Now, to find horizontal asymptotes, you have to remember the rules again. So we would need to go back up and look at the function a little bit. We need to determine the degree of the numerator and the denominator. Now, in this one, the independent variable is t. So I'm looking at the largest power of t, which is this term here. Both of them have a 1, so they have the same degree in the numerator and the denominator. So that means your horizontal asymptote is going to be y equals, and then your leading coefficients of the numerator divided by the denominator. So you can do that in your calculator, or you might be able to do it by hand also, just in your head. You should get y equals 800. Okay, so then they ask us to kind of interpret what that horizontal asymptote means. So what does it tell us about this situation? Now, the y values are your deer population, and an asymptote is kind of giving you a boundary, a limit for what's going on. So when they ask you what the horizontal asymptote tells you about the problem situation, if it's y equals 800, then that would mean that the limit of the deer population in that reserve is 800. Now, that's kind of an interesting concept there. You would think that if they're in a reserve, maybe the population wouldn't have any limit whatsoever. They could just keep breeding and making more deer. However, the land that's there can only support a certain amount of population. So at some point, there's not enough food or not enough space for each of those deer. So there is actually a limit. So that means the number of deer in that reserve would never be more than 800. Now you'll try example number 6 and then answer the questions on the